Hi guys, welcome to the first module made by Microprocessor and Interfacing Laboratory, which is commonly referred to as UPCI Laboratory. Now let's check the objectives of this module. There are several objectives of this module. The first one is to understand the system of microprocessor, microcontroller, and microcomputer. The second one is to understanding the minimum system of microcontroller. The third one is to be able to carry out instruction on the microprocessor. The fourth one, be able to do memory addressing. And the fifth one, knowing and understanding the function of pins on the AVR microcontroller, ATmega 8535. Okay, now we're gonna learn about microprocessor. Uh, what do you think microprocessor is? So microprocessor is a single chip that contains digital circuit to perform arithmetic, logic, communication, and control function by executing instruction or program in a specific order. Unlike electronic hardware circuits such as digital IC or circuit or release-based system, microprocessor have the advantage of high flexibility because changes can be made by changing the programming of the software. So there are several parts of microprocessor. Microprocessor consists of three parts. The first part is about register. Registers serve as a temporary storage of data, addresses, instruction codes, and status bits for various microprocessor operations. The second part is ALU, or Algorithm and Logic Unit. ALU functions to work on logic commands and arithmetic operations. The third part is Timing and Control Unit. Function to retrieve and decode instruction from program memory and generate control signals needed by other parts of the microprocessor to carry out this instruction. So this microprocessor is controlled by CPU. CPU works to regulate the control and data transfer process that occurs in the system microprocessor. Data transfer takes place through a channel called the data bus. Data transfer can occur from memory to CPU or from input or output to CPU or vice versa, from CPU to memory or from CPU to input or output. Data transfer from memory or from input or output to the CPU is known as the read process or read. So let's get to the next part. Function of the microprocessor. The main function of the microprocessor is a unit that controls the entire work of microprocessor system, moving data from and to memory, taking instruction and data from memory, sending control signals and serving interrupt signals, provided timing for the work cycle of the microprocessor system. And the last one is to perform function, logic and arithmetic operation unit. I mean function. Okay. The step of the processor is carrying out an instruction. So the first step is the pick up instruction or we say instruction fetch or EF. Is the process of taking instruction from a location with a specific address in main memory. The second one is about decoding of instruction or instruction decode that we used to call it ID. So this is the process of translating codes by existing instruction tables to find out the purpose of an instruction. Then, the next process is execution of instruction or EX, execution. From the result of the decoding, we'll get the intent of the instruction. So the processor will carry out function according to the instruction. Now is about microprocessor register. Wait. So the first one is BIU, Bus Interface Unit. As an interface or addressing with peripheral outside the microprocessor, responsible for all external bus operations such as instruction fetch or EF, memory read-write operation or input or output, QU instruction and address calculation or PA, and now EU, execution unit. So execution unit is about translating instruction or instruction decode, execution instruction, and etc. And wait, so this is the so above me is the architecture of microprocessor. Wait, so there are several types of register in microprocessor 8088. Uh, we take this as an example. So the first is general purpose register, the register accumulator or AX, base register or BX, counter register or CX, and data register or DX. Okay, the second one is pointer register. Pointer register is consists of stack pointer, base pointer, and source index and destination index. Then we have flag register, a special 16-bit register with a single bit position that is assigned to indicate CPU status or the result of operation arithmetic. And then we have segment register that consists of five. The first one is code segment, data segment, stack segment, extra segment, and instruction pointer. Okay. Now we're gonna learn about microcontroller. Okay. Microcontroller. A microcontroller is a functional computer system on a chip. It contains a processor core that we talked about before, memory, a small amount of RAM, program memory or both, and input-output equipment. So they can interact with maybe other microcontroller or other component, I think. Okay, now microcontroller. In order for a microcontroller to function, the microcontroller requires external components which are then called the minimum system. To make a minimum system, at least the system clock and reset are required. Although some microcontrollers already provide an internal clock system, so that even without an external circuit, the microcontroller can work properly. Okay. So now it's about microcomputer. Wait. So what is microcomputer? What is the difference between microcomputer, microcontroller, and microprocessor? So microcomputer is an interconnection between the microprocessor or CPU and main memory, an input-output interface or I/O interface, which is carried out using a bus interconnection system. As an example of the microcomputer itself is the Raspberry Pi part. The microcomputer part consists of microprocessor, main memory, RAM or ROM, and input or output pin. Okay, wait. So the next part is microcontroller minimum system. So microcontroller minimum system is a circuit that is designed using the minimum possible component to support the work of the microcontroller as we want. So this is the part of block diagram. We have microcontroller, the yellow block, power supply, input or output, oscillator, serial, and reset. Then we're gonna learn about AVR. The AVR, Off and Regard RESG or Advanced Virtual RISC microcontroller was then further developed by Atmel. The first AVR series release was the 8-bit AT90SA515 microcontroller with the same pin configuration as the X05E X05 X051 microcontroller, including address and the multiplex and database. And the last one, we're gonna learn about ATmega 8535 or 8535. So ATmega 8535 is a 8 CMOS microcontroller bit, low power based on RESG architecture. The instructions are carried out at 1 cycle clock, and Atmega 8535 has a throughput approaching 1 MIPS or million instructions per second per megahertz. This makes the Atmega 8535 can work at high speed even with low power usage. So you can see above me, there is a picture of microcontroller Atmega 853, which is consists of three parts, the A part, B part, C part, and D part. Okay, that's all for the first module. If you have any question or maybe you need some more detail, you can check the module at the description. You can download it right now. Don't forget to like, subscribe, and comment in this video. And good luck for the practicum. Thank you.